All right, hey guys. So I'm going to show you how to do this in StatCrunch, okay, which will make your life a lot easier. It's also going to be what you're primarily going to be using on the homework, but it's still good to know how to do this by hand. So when you do this on StatCrunch, what you're going to do is you're going to go to Stat, Proportions, since we're testing the probability of something that has to do with percentages, One Sample with Summary. So we got 7 heads out of the 20 times that we spun a coin. Now, our hypothesis is that p equals 50, so we're going to have a 50-50 chance. And then we just thought that the coin was unfair, so we think it's going to be not equal to. Then we hit compute. And we are going to get all of this wonderful information. So we're going to get a sample proportion of 0.35, which is what we got, a standard error of 0.1118, our z-test statistic of negative 1.34, and then a p-value of 0.1797. So let's compare that to what we got. So we got a z-score of 0.0749, which we multiplied twice, and we got 0.1498. So not looking too bad. That looks pretty good, especially for us approximating. Okay, so let's go ahead and look at the next example. So if the central limit theorems have been met, that means that we have a random sample with at least 10 successes and 10 failures, and a large enough population, then we can use that z-test and find the significance level. So we pick that before we do anything else. Then we find the test statistic, that is the z-value. And then we find the p-value using that z-score. Okay. So remember that from the observed z-score of our sample, the p-value is probability that we see such results if our null hypothesis is true. So that is, remember, if p is low. All right, so big example. Okay. In the state of Oregon, biologists conclude that 32% of freshwater fish contain high levels of mercury. We wish to see if rainbow trout have a lower proportion of fish, or proportion of fish with high levels of mercury. We collect 110 trout randomly and find that 24 have high levels of mercury. This gives us a sample proportion of 0.22. Okay. So we wish to carry out a hypothesis test to determine whether the proportion of all trout in Oregon have a low mercury level than the freshwater fish population. So our null hypothesis is that trout are the same as all other fish. Our alternative is that we think that they have lower proportions with high level of mercury. Now, for part 2, we want to choose a level of significance and check the conditions of the central limit theorem have been met. So we're just going to set a pretty standard one, 0.05. And the first condition is it rando? Yes. The reason it's random is because we said that we randomly sampled them. Okay, 2 is we want to make sure that we have enough successes and failures. So the number of successes would be 110 times. Now remember, we are checking that we have the right number of successes if we have a sample of 110, if we do this over and over and over. So even though we saw 24, it's what would we expect if the null hypothesis was true. So we're going to multiply that by 0.32, and that is going to give us about 35 successes, which is greater than 10, so that's good. Then the number of failures would be 110 times 1 minus 0.32. So remember, if you're not in the 32% that have high levels of mercury, then you would be in the 68% that didn't. So if we do 110 times that 1 minus 0.32, what we will get is about 75, which is also greater than 10. So we have enough successes and failures. Now the third step is the population large enough? So do we think that the state of Oregon has more than 1,100 trout? And the answer is yes. Even though we don't know exactly how many they have, it's probably more than that. The next thing is that we want to find the test statistic. So first we need to find the standard error. which would be 0.32 times 1 minus 0.32 divided by 110. Okay, which would roughly give us 0.0445. Okay, so then the z-test statistic would be 0.22, so that was our sample proportion that we found, minus 0.32 divided by that 0.0445, and that would end up equaling negative 2.25. All right, now what we want to do is find the p-value and determine if we accept or reject our null hypothesis. So remember, if we draw a normal curve and we suspect that 32% of freshwater fish have high levels of mercury, but then our alternative hypothesis is that they actually have less, okay, then what we're looking for is that we're looking to find the area to the right. Okay, and that's where the 22% is that we found in our sample. So that p-value, we are going to look at our z-score table and look at where negative 2.25 is, and we're going to get 0.01. All right, so since this p-value is less than alpha, then we can reject H0. That means that we found evidence that these fish actually do have lower levels of mercury than regular freshwater fish. All right, so let's go ahead and do this one, and let's do it in StatCrunch just to check our work. So remember, we're going to go stat, proportion, one sample with summary. So we had 24 out of 110 that had high levels of mercury. And we thought that the original proportion was 32, and we wanted to see if rainbow trout had a significantly lower amount. So when we run this in StatCrunch, what we are going to find is our sample proportion is about the same. Our standard error is about the same. Our z-stat is a little bit different just because we rounded differently, and so is our p-value. Again, only because we rounded a little bit differently. But all of these values are very close. Alright, so what I want you guys to do is I want you to pause the video and I want you to try the next two examples on your own and check your work on StatCrunch. And then I want you to check your answers against the solutions that I have posted on Canvas.